This looks more complicated. Notice that things are added. When things are added, they get grouped together, or subtracted, they get grouped together. So right now, all of those four things would each be separate things, and the only way you could simplify is if you're multiplying, which technically those blue things are multiplied together, but only if they're identical on the top and the bottom, and none of those are identical. I cannot cancel out this x squared with this x squared, because that is part of the bigger blue set of brackets. So the strategy is to factor first. First one, can you factor this? Well, x squared would be x and x. 20 would be 5 and 4. They'd both be plus. After you factor, you should always multiply it out to double check. I have to do this one in 2 steps. Put the brackets at the bottom. But I notice that on the bottom one, there is a common factor of 2. If you have a common factor, you should take that out first. That leaves me with x squared plus 3x minus 4. Next, x squared minus 1 is a difference of squares. That can be x plus 1, x minus 1. And 3x plus 5 has a common factor of 3, x plus 5. Am I done factoring? No. Right? We still have one quadratic left to factor. However, I might notice I can at least cancel out the x plus 5s are identical now. So I could do that. Next, I will rewrite. I'm left with an x plus 4 on the top of this one. I'm left with a 2, and now I can factor this. And the beautiful thing about this unit is they kind of give you hints with factoring. Like, ooh, one of them might be a 4. Will it be 2 and 2 or 4 and 1? Well, the top has a 4 and a 1. It would sure be nice if it canceled out. And the teachers that make these questions have just as much fun canceling things out as you do. So I'm going to guess that one of these is x plus 4. And if it's x plus 4 that I guessed, can you see to get x squared, this would have to be x. And to get a minus 4, this would have to be minus 1. And now I just check it because I didn't actually factor it right. I cheated. I stole a factor from above. But sure enough, 4x minus 1x gives me plus 3x. It works out nicely. On this one, I'm left with an x plus 1 and an x minus 1, and I only have the 3 left on the bottom. So beautifully, this x plus 4 can cancel out with that x plus 4. And this x minus 1 cancels out with that x minus 1. Anything left to cancel out? Doesn't look like it. So what do I have left? I'm left with, on the top of my fraction, just an x plus 1. On the bottom, I'm left with 2 times 3, which would be 6. Now we have to check everywhere that we divided. And in checking everywhere that we divided, I'm going to check for factors. There's a factor. I'm dividing. I'm dividing by this. Actually, I'm going to highlight that. And you see that this part in blue ended up changing into this? So now when I go to list my non-permissible values, from the yellow one, x can't equal negative 5. From the blue ones, the factored one is easiest to see. X can't equal negative 4, and x can't equal 1. You highlight the red with the brown? That's like a brown. That's so cool. Makes me think of chocolate. No, it's not. That's good chocolate. Oh, now I'm sad. I don't have any chocolate. Okay. Well, we're not going to erase that because that color is very happy. But we'll do B. And to start off on B, we notice that we're dividing. So before I even start to factor, I'm going to rewrite the first one, 3x. Well, I might factor this out because it's just so easy to factor. But then I'm going to change the second one to multiply. And I'm going to flip. And if I have any common factors, and I do, I'm going to take those common factors out. So on the 3x squared at the bottom, I can take out a 3. And that would leave me with x squared minus 4x minus 21. And on the 3x squared minus 12 at the top, I can take out a 3, leaving me with x squared minus 4. Can I factor anything else? Absolutely. But I might, just to save myself some time, say, hey, those I can cancel out. At least I don't have to write those again. So what do I still have? I still have an x minus 2. I still have a 3 times an x minus 7. Multiply by. Here, x and x. 21, you could cheat. Oh, there's a minus 7 on the bottom. Let's say, I hope there's a minus 7. If I said minus 7, this would have to be plus 3. Double check when you multiply it, it works out perfectly. Shouldn't teach you how to cheat. I don't know. I'm mixed feelings about that. And that's the difference of squares, x plus 2x minus 2. Now we're multiplying. If a factor is identical when you're multiplying, you can simplify, because it'll be equal to 1. So our x minus 2 will cancel out with our x minus 2. And, oh, those would cancel. Anything else? Can I cancel this 3 with this 3? No, because this is grouped together as one factor. That x plus 3 is together. The only way you could cancel it out is if it was identical.
Can I please have Norman, Nikita, and Matt office?
Yeah, they'll be right down. Who's that? Norman and?
Norman, myself, Nikita, and Madison.
Nikita? Nikita? You got called down to the office. Madison? It's probably because you haven't, the academic awards is coming up, and you probably haven't RSVP'd yet. If you're coming or not. You have to go to the office. Yes.
Oh, I think we do after.
Okay. So now, what is left as a result? We are left with an x plus 3 on the top and a 3x plus 2 on the bottom. If we want to list our non-permissible values, I'm going to take out my highlighter again. I'm going to use green. There, I'm dividing. And I'm dividing, oh, you have to be careful. Because you're dividing here. I'm going to change the color of that one. Oh, I'm going to use purple. And that is disgusting color. Oh. All right. We got our purple there. What happened to that purple when it was on the bottom? Can you see that purple ended up going here? Ooh, that's pretty good. And then it became there. And then we're also dividing light blue right here. orange and blue made green. That, yeah, that's amazing. So we'll do some orange and blue off to the side after, because that's cool. Okay, so I highlight all the places where we divided. The tricky one with division is for you to remember that originally this was in a denominator. But once you flip it, it went to the numerator, but those are still non-permissible values. So when we go to write our non-permissible values, x can't equal 7 from the green one. From the purple one, x can't equal 7, we already had that, but we also have to include x can't equal -3. And then from the light blue, we have x can't equal 2, and x can't equal -2. There are 4 non-permissible values in this. Where did I get the -3 from? The purple.
But it's on top.
It's on the top. That purple came from that purple, which was on the top. And that purple came from that purple, which was on the bottom. Ooh. Was I right? Do you want to know what you missed? Yeah, you want to know what you missed. You missed. You missed this. Wait for it. That's cool. Someone. This little spot. Oh, and wait a second. It made it greener. No, it's as green as it's gonna get.
Mix it with purple.
I think the purple, I don't know. I think the purple will get disappointing. It'll get too dark.
Wouldn't it be red?
We can try.
It's just maybe. Never mind.
Ooh.
Fine.
That was kind of enjoyable. I
Brown
didn't
now?
mind that. I didn't mind that. I thought I would be disappointed. But I wasn't.
Yeah.
Ooh. This is like, I should stop videoing.
This is all on the video.
We haven't done this one yet. Did we do this one?
This is green.
That's what we mean. No.
This is just so there's now just going to be a section of the video.
Oh, wow. No, that one wasn't as enjoyable. I do, right, right away. Put that one away. This one away. I like this one. But this is still green. Even though it was.
What about the purple one?
Oh, no. This is, now it's kind of, I'll probably sell this as artwork for like thousands. How do you make one of those digital, you can make it a digital, like, NFT thing?
Oh God, don't
Right? Put it on.
You can sell that as modern.
Yeah.
Fits the belt.
Right? Please contact the school if you would like to buy this. Anyone on YouTube watching? There we go. All right. That is saved.